Okay, so now I'd like to tell you something about higher layer, so network layer. Regarding internet, this is a very important layer which led us to transfer data between different kinds of network. So the most important feature of network layer is to find a route between two points which are not neighbors. So in data link layer, we were able to send data to nodes which are neighboring nodes, so which are directly connected with us. Here, we have the higher abstraction. So we want to find path which connects 2 points via neighboring nodes. What is important that datagrams which are delivered at this network can be, so delivery process may fail, so it's not guaranteed. So look, okay, why? Something is mixed here. So in network layer, the most commonly used protocol for network layer, and it is used for all networks layers in internet, is IP. So it is called Internet Protocol. So using this protocol, every host is identified using IP address. So the address, which is common for all nodes in internet. So it led us to find the path or route between two nodes, even they are located in different countries. So how it works? So if we have IP address, it is impossible to plan the route globally. So for example, my computer doesn't know where the particular computer is. But based on IP address, it decides where my packet should be transmitted. So to which neighboring node it should be transmitted. So using IP address, my computer or client side decide, okay, it should be transmitted to router, and it is because the router is neighboring node, so it is transmitted using data layer, and then this router unpacked the IP protocol and verifies IP address and decides where it should be transmitted then. And it is transmitted somewhere else, and every node decides where it should be transmitted. So finally, this package arrives to client or to server to destination point. So look. So look, I'd like to show you how my package is transmitted to, let's say, WPPL service. So here I have my computer, then the package is sent to my router. From my router, it is sent to another device. This is my GSM router. And then from GSM router, it is sent to, another server, and then to another server, and finally to somewhere where WPSA is. So you can see that this process consists of, several steps, but finally it should reach destination. But I'd like to tell you that, okay, route planning is very complex issue. So if you would try to do it like, okay, I'd like to find somebody who knows Donald Trump, for example, and I ask my colleague, okay, do you know Donald Trump? Not, okay, so, but send this package further, yeah? So you send package in blind mode, so to, any node, and you hope that finally it reach destination. Okay, it doesn't work in like that. So in internet, it doesn't work like that. So the routers, maybe not our home routers, but our ISP, routers of our ISP, so internet providers, has some knowledge about the network architecture, so about where particular address can be found. So they use something which is called IX or IXP. So this is physical infrastructure of internet. There are some nodes which has some, or creates or build a dynamic maps of internet regarding both the network's localization. So we are able to localize particular computer. And the second feature of IXP is that they monitor the load of particular nodes. So they are able to transfer a package using a route which is not so busy. So they try to maximize the delivery time or minimize delivery time. So it is done on IXP facility. So here you have a map. Yesterday I told you about the first transatlantic cable, which connected Europe with United States. In 2007, this network was much more, complex. So we have many fiber optic telecommunication cables around the world. And now we have also a satellite transmission connection. So we can stream a lot of data. But you can see that this network is quite complex. So we can send the data in many routes using many ways. So IXP decide which ways should be or will be the best one. But if we have IP protocol, it is used only to find a proper path between nodes. But to transfer data from one node to another node, we have to use a higher layer, which is called a transport layer. So in fact, in transport layer, we are able to send particular set, or maybe not only send, but we are able to exchange data between two hosts, even they are not connected together. So in network layer, the path is planning. So we are able to find the proper path. In transport layer, we have mechanism which is able to establish connection between two applications, which works on two distinct computers. So in fact, in transport layer, we have two protocols available. So one of them is called TCP, Transfer Control Protocol. So it connects two hosts or two services, which are, or daemons, which are run on host. It led us to verify or validate whether data are correct or not. And it has also a mechanism which led us to retransmit data. So using TCP protocol, we are able to get data, to verify their consistency, to get data again which was broken. From user perspective, when we use TCP protocol, it is similar to use files. So I write data to particular, let's say, service, particular file, and on the other side, I can read data from this side. So from when we use the communication in transport layer, the user don't need to know, or he or she don't need know nothing about the internet connection, because it writes data and reads data on opposite side. So it seems that there is like a direct connection between them. Even data are transferred using many hubs. If we look at the TCP communication frame, the header of this frame consists of several fields. So it consists the source and destination port number. So it's not address of IP address of computer, but it's number, let's say internal number. Huh? So we have up to 60,000 different ports in a single computer. The second element is sequence number. So sequence number refers to the number of package which was sent. So look, if I send message, I have to split it into packages because the size of single data frame is limited. Depends on network, but it is limited to 1 or 4 kilobytes. So if I need to send more data, I have to split it. And here I can enumerate packages. What is the benefit? The benefit is that because we can send data, or IXP decide to send data on different routes, it may happen that the package which was sent as the first will arrive later than the package which was sent as the second or further. Yeah. So in this case, to combine these packages, we use a sequence number. So the TCP protocol let us to also to merge messages which were sent in, you know, opposite or in order which is not the proper order. And what's more, we are able to detect that some messages were lost because, okay, the sequence number will be not consistent. Every package which was received by which was received or delivered is a knowledge. So so the sender is informed that particular package arrived. So look, if I send something, the other side confirms, okay, the package was received. If the package was broken, it informs me that the package was broken and there is a retransmission request. So what happened if the package lost? So if the package lost, I will not get the acknowledge from receiver. So after timeout, so there is a particular time in which I expect to get acknowledge. After this timeout, I can inform, or the user is informed that, okay, the server is unreachable, so I can't get to it because package was lost. So I can decide whether to try connect or connect to it again, or I can do it or react on this event different. The checksum is a very important field. So checksum let us or let receiver to verify the package consistency. So it let to calculate some value from all data bytes which were received and verify whether this value is equal to checksum which is presented here. If yes, it assumes that everything is okay. So the package was transmitted correctly with no errors. If there is a difference, it means that some bits were corrupted. So it acknowledged that the package was received, but it was broken. So look, this protocol is very, you know, powerful protocol which let us to send data on very high, not performance, because you can see that if I send data to send my package, every package is acknowledged by different another package and so on. So there's a lot of packages which has to be sent. But this service guarantees that data will be received and will be consistent. Of course, there's another phase which follows the transmission phase. It is called a connection phase. So if I'd like to use TCP, the three packages has to be exchanged. So three packages between host A and host B has to be exchanged before the real data will be sent. This connection or this way is, or this method is called three-way handshaking. So in this process, the connection parameters are set. They refers to frame size, the timeout. So there is the transmission time between sender and receiver is measured, and based on this time, the timeout value is set, etc. Why it is called three-way handshaking? Because it works like that. The host A sends to host B a request of connection. The host B confirms to host A that it received this package and some parameters are sent. And after that, host A confirms it again. So three packages has to be exchanged before data will be sent. So therefore, it is called three-way handshaking. The alternative for TCP is UDP, so User Datagram Protocol. So the difference between UDP and TCP is that there are no connection between client and server. So this three-way handshaking phase is not processed. So I can send packages to particular address, but I don't know whether these packages were delivered or not, or I don't know whether these packages were broken or not. So using UDP, we can achieve a higher throughput because there are no additional packages which confirm something. There are no timeout where I have to wait for confirmation and so on. So UDP doesn't guarantee that data will be delivered, and okay, TCP also doesn't guarantee that data will be delivered, because if the computer is disconnected, okay, so it's impossible. But for TCP, I will be informed that it was failed because I wait for the reception acknowledgement. So if it will not be received, it means that something was broken. Here, not. So in this case, our UDP protocol is usually used for data streams, so for video or voice streaming, where receiving every package is not so important. But for streaming information which are vital for us, and we want to achieve data consistency, we usually use TCP protocol. Okay, so but remember that it doesn't matter whether we use TCP or UDP, we need IP protocol, because IP protocol let us to find the proper path in network. So now I'd like to tell you something about IP addressing. So in fact, we have two different versions for IP addressing. So we have IP version 4 and IP version 6. They are used together most routers use IPv6 now, but I will show you that IPv4 and IPv6 are, IPv4 is a subset of IPv6. But several years ago, IPv4 was the standard for communication, and it was standard for, let's say, 30 years. But it has some limitation. So let's start from the IPv4. So IPv4 consists of 4 bytes, but this address contains or consists of 2 parts. The first part is called network address, and the second part is called the computer address. But in fact, how many bits corresponds to network address and how many bits corresponds to computer address depends on something which is called IP class. So I can divide IP addresses on different classes. So we have class A. The typical for this class is that the most significant bit is 0 here. And for this class, first byte is taken for network address, and 3 bytes are taken for computer address in this network. So in fact, because this bit is 0, I am able to address up to 126 different networks. But in every network, I can have 8 to power 3 different computers. So about 16 million computers. But of course, all addresses of network A are taken and mostly occupied by US Army. Yeah? The class B, 2 octets or 2 bytes are taken for network address and 2 bytes are taken for host address. So we can have we can have up to 64,000 hosts, and I don't agree with this this value. Range, but we can have about 60,000 or 30,000 devices, networks. So one important thing, the route planning based on IP. So if the router is able to extract the network address, it is able to point out where particular network is. So using IP addressing, not computer is localized, but first the network is localized. And when the particular network will be reached, in this network, the particular computer is localized then. So this distinction on different networks and what is the network address and what is the host address is important for path planning. So in class C, 3 bytes or 3 octets are taken by network address and 1 octet is taken for computer address. So in this network, which is the most commonly used network private LANs, it is like this. So we can have up to 254 different computers connected. I'd like to tell you that usually when we specify the IP address, we also specify something which is called a mask. So mask refers to part of the IP address, which is the address of network, and the part which is the address of the computer. So for example, if we have mask like this, 255000, so in binary, it's the first byte takes 8 times 1, and other bytes are 0. So you can see that this is the address of B class, of A class, sorry. In this case, if we have 255 so 2 first bytes are taken for address and other are 0. This is address of B class and so on. Sometimes we can, okay, maybe I will show you it. Okay. Okay, so when we configure the address of device, we can specify the net mask, but sometimes you can find that this mask is expressed as after slash. So I have 192.168.41. So this is the IP address of the device, slash 24. So 24 means that there are 24, so first 24 bits are equal to 1. So this is equivalent to the class C. So 255, 255, 255, so 24 bits, 0. So usually you can find the notation of mask notation, which looks like this, or which looks like that. So the IP address led me to identify the computer in network, but the problem is that if we have 4 bytes, in theory, we are able to address 8 to power 20, we have 4 bytes, so 32 bits. So we are able to address 2 to power 32 computers. 2 to power 32 is not so huge value because the number of devices which is connected to internet is higher. So it is impossible to localize using IPv4 to localize every computer in internet. So how it was solved? Some ranges of IP address are used as private addresses or private networks. These ranges are like this. So class A, then, and here we have 3 bytes, which can be, any, which specify the address of computer. We have 16 networks of class B. So these two octets are used for computer addresses, and the network address is 172.16 up to 172.31. Yeah. And the most commonly used, so we have 255 networks of class B. So we have 192.168, and the network is from 0 to 55. So this least significant byte is taken as a computer address. So for routers, this is the most commonly used network address we can use. So look, if we have a local area network, all computers which are connected to this network has IP address. And this IP address belongs, or the first part of this address specifies the network, and this address has to be the same for all computers which are here. So look, if I have network of class C and the network address is 192.168.0, it will be in common for all computers which are connected. But every computer will have different computer address. So you can see that there are different addresses of computers in 192.168.0 network. And here we have, let's say, a computer which is called a router or bridge. Here we have a router or bridge. So what the router is? The router is the computer which on the edge of two networks. So it has at least two interfaces. The one interface for local area network, and this interface address is like this. And the other interface is for something which is called wide area network. And the address of this interface has to be different. So look here, I have here more than two interfaces, but let's assume that I have the LAN interface, which is 192.168.4.1. Okay, so this is the address of my network, and the address of the router in this network is this one. And on the other side, I have the network which address is 192.168.8, and the address of this router in network is 99. So this is the typical for router, and the second parameters for this address is a gateway address. So gateway address is the address of the router, or the, let's say, the router in this network. So the computer which is somehow a window for next wide area network. So look, the structure is like that. Here I have the LAN network. So here in every place I have the different computer, and they shared the same address. Here I have a router, and this router has at least two ports. So it has LAN port and it has WAN port. And here I have another network, but in this network, there is again a router with LAN address and with wide area network address. So of course, I can have here more computers, but what is the important? If the address is 192.168.899. So this is address of the one interface of my router. And here I have address 192.168.4.1. I don't know what's going on with. Okay, so sorry. So this router has address 192.168.8.1. So this is the address of this device when you look from the inside this network. But on the opposite side, its address is different, so it belongs to different network. So when I send package, it is first sent to this router, and then this router sent this package to the next router, and so on. So look here, when I sent package, it was first transmitted to open VRTLAN, then it was sent to 192.168.8.1 and so on. I'd like to show you, but if we have IPv6 address, it consists of 128 bits. So in fact, we are able to store 2 to power 128. So in theory, we are able to address every device in network. So every wash machine or cooker device which can be connected to internet. So regarding the process which devices which are announced as IoT, so Internet of Things. So Internet of Things aims to connect to internet every device in network. So not only mobile phones, but all kitchen machines, cars, and other device. So in this case, this number of or this size, it's enough to connect every device to internet. So this address consists of 8 fields of 16 bits. We can to make it shorter, if there are zeros somewhere, we can shrink them, so this address can be made shorter, but even it is hard to remember. But in IPv6 we have 3 types of addresses. So we have unicast addresses. So they are assigned to individual interface. So like IPv4 address. We have multicast addresses. So they are assigned to group of interfaces. So for example, you can imagine that we have wash machine with multicast address, and the manufacturer can send to all wash machines, for example, hardware or firmware updates. Anycast address, so it's similar to multicast, but the packages are delivered only to the first or nearest node. There are different aspects of IPv6. I think it's not worth to, to learn by heart what particular values means, but you should know what are the ranges or types of addresses. So we have link local addresses, like I showed you for my computer. So they are used to communicate in single network. So they are treated as private addresses. Then we have a unique local addresses. And we have global unicast addresses, so they are accessible from any localization in internet, so they are treated as public. And the most addresses, IPv6 addresses, are global unicast addresses. We can have also the IPv4 over IPv6. So if we have IPv4, the last 4 bytes of address are like this. So the last 4 bytes are presented as the values of IPv4, while the first bytes are 0. So you have shrinked 0 here. Here we have FF. So we can present every IPv4 address using IPv6 protocol. So in fact, every computer which you connect to network can have a default IPv6 address, and this address is created based on 64 bits of network prefix. So let's say network address, and 64 bits of the MAC address. So the MAC address creates this second part of IPv6 address, and it is called auto configuration. Okay, so now I'd like to tell you something about the. So this is the summary of IP addressing, in fact. So we have 3 local area networks. So they are connected by routers. And here we have a server, and here we have internet access. You can see that the addresses of these networks are private addresses, so they belongs to private networks. So again, what does it mean that the network is private? So it cannot be accessed from the internet because this network can exist in many different local area networks. So there can be many computers of this address. So usually when you have a router, but let's say something which is called edge router, so the router which connects your network with structural internet, so not here. This addresses, or when there is a request to private network address, this package is not sent to internet because there are no path to find such network. Okay, but here we have 1, 2, 3 networks. The networks are class 22. So it means that the first 22 bits are the network address, and remaining 10 bits are the computer address. So in fact, when I'd like to verify what is the network address here and what is the computer address range, I have to so look, I have 172.16.0.0. If I have 22, maybe I take document here. Okay, so let's try to do it like this. If I have 172.16.0.0, and here I have mask 22, it means that I have 1, 1, 1, 1, 1, 1, 1, 1. So 8 times 1. Here I have again 8 times 1 is 16. And here I have 1, 1, 1, 1, 1, 0, 0. So look, the network address here has to be masked using this this value. So on this octet, 2 bits are taken for computer address and other 6 bits are taken for network address. So if I, for example, if I'd like to send package to computer of address 172.16 uh, 254.1. So if I'd like to verify it, whether it belongs to this network or it is localized outside the network, I have to make binary AND operation with this address. So the network address will be 172 because, you know, we have 8 times 1. So here, when I perform AND, the same value will be obtained. Here I have also 8 times 1, so 1, 1, 1, 1, 16. And here I have 254. So 254 is 1, 1, 1, 1, 1, 1, 1, 0. So to verify what is the network address here, I have to perform AND operation with mask. So I have to perform AND operation of 254 with this mask. So the computer, when I perform it, I get something like that in binary, 1, 1, 1, 1, 1, 1, 0, 0. So it will be the address of computer, and here I have 0. So the address of network. So the address of network is 172.16, and here is 152, I guess, 0. So this is the address of network when I applied the mask. So what does it mean? If I'd like to send the package to computer of this address, it belongs to different network than our network here. So therefore, the router has to send this this package outside. Okay, so this is the one info about the networks which has not fully, so where the octet is split between network address and computer address. But what is more interesting here? Look, here I have the massive or server, and this server contains some applications and data. You can see that these computers they have a private addresses. So it is impossible, okay, for hacker it is, but it is impossible to get this computer from the internet. So it is impossible to write address 172.16.00, say 1, and to access computer from internet. To access the computer from internet, I have to have something which is called a public address. So usually we have, or we can have, a single or maybe 2 public addresses. So this public address is assigned to the, let's say, edge router, so it can be firewall or something like that. So it has the public address of our in internet. So in fact, I am able to connect from the internet to this device. So how we can allow to connect with other computers? Usually on the router we can okay, on routers, usually we have something which is called a port forwards. So I told you that if we use TCP or UDP protocol, we send data not directly, not to IP address, but the connection reach to particular port. So when, for example, I'd like to connect with certain service, I have to specify not only the address of computer, but also the service internal address. So, for example, if we have several services available, the router is able to forward packages which were sent to public address to particular ports. So for example, here, look, I have, if there will be sent a package to port 1194, it will be forwarded to address 19.168.4.12. So it will be forwarded to particular computer in LAN network, even it utilizes the private address. So this is the method how, having a single public address, we can send or distribute packages inside network. So from the user perspective, it seems that it connects with a single address, but in fact it connects, when it uses different port addresses, it can connect with different computers. So this is called a port forwarding. Oh, sorry, oops. I see that. Okay, so here, sorry, because I have two displays. So, so look, in firewall option in every router, you can find something which is called a port forwarding. And in this case, when for the router or firewall receive the package which is addressed to port 1194, it forwards it to address 192.168.4.12. Yeah, so this is the way how we can redistribute packages or services in our network, even we have a single public IP address. So remember that TCP protocol cannot exist without IP protocol. So IP protocol is the fundamental protocol for internet. And even we use TCP or UDP, always on network layer, we have IP. So TCP protocol seems to be the most commonly used protocol. We use it for connect to web browser with email client, with any other services you used in daily life. But looking at the ISO OC model, the TCP takes the transport layer, IP network layer, then we have data link layer and physical layer, but other layers are not addressed in this protocol. So they are combined in application in which utilize TCP IP. Now, I'd like to tell you something about sockets, because I mentioned that sockets, using sockets, it's typical for TCP, it's typical for also for UDP. So when I'd like to connect with computer, I don't connect with, IP address, but I connect with internal port on the computer, which is localized using IP address. So this is similar to, corporation, where we have two modes of operation. So we can have a reception, and every call is directed via reception. So there is a guy who, asks you, oh, what's happened, and try to think who can handle you. And the second option is using internal numbers. So you call not only to the, this company, but you select the internal number of particular so the particular section of this company. So in this case, the reception, in this case, so if you use internal numbers, the reception doesn't handle such calls. So the same is with sockets. So if I use sockets, I connect to particular service in on server. So there are no need to, that the server should decide, which service should handle me or my request, because I connect with specific application. Usually the socket numbers, so it is 2-byte number, can be specified after the IP address number. Some numbers are attached to services, like 80 is attached to HTTP, 21 to FTP, and so on. The number greater than 1000 are available for customer application. So here you have a list of the most commonly used ports and services which are attached. So HTTP, everyone use it. If you use HTTPS, the port is different, it's for free. I don't know whether you use SSH. It is very commonly used protocol to connect with the servers and terminals. SMTP is used to connect with with mail server to send mail. POP3 or IMAP is used to receive messages from mail server. Okay, so now I'd like to tell you something about security issues, because having network, it's good to understand how what is ISO OSI model and what is TCP/IP protocol. But I think that difference between socket and port. Okay, it's the same word for. So there are no difference if we talk about network communication. The port and socket they mean the same. Yeah? So so now I'd like to pay your attention on security issues. Not every security issues, but some issues. The first issue is that we should you should know that if you send messages on internet, they are sent via different routers and devices. So on every stage, they can be intercepted. So it means that they are in fact publicly available. So now I'd like to show you a single example. Okay. So look, here we have a webmail client. So I can connect with my mailbox, but I will run I will run something which is called a Wireshark. So Wireshark is the application which let me to intercept all packages which are sent from my device, but it is possible to install such application on different nodes. So in theory, everyone can do it. Okay. So now, because I'd like to connect using HTTP protocol, I'd like show you what's going on here. So look, here I have to specify username. So let's say ABC IBPL. Okay, and the password. And the password, which I have to specify, will be 1, 2, 3, 4, 5, 6. Okay, it's hidden. There are dots, and now I run my. Okay. So wait a moment. Okay, so I'd like to capture this interface, maybe wireless interface too. And for me, okay, so I apply it, and now I run login. Yeah. Okay, so I stop capturing data, and now I try to filter it. So I select only packages which were sent to HTTP protocol. So and look, here I have package which was sent to webmail task login, and here I can see the package content. So in this content, I can find the value user ABS and password 123456. So look, even this password is hidden. It seems to be hidden only for me, yeah? Because here it is transferred using plain text. So it is easily, it can be easily captured and taken. Yeah. So what is the problem here? The problem here is the information that this connection is not secure. Yeah? So it is not encrypted. So what shall I do? I should to use HTTPS, for example. When I use HTTPS connection, okay, I get information that your connection is not private. I will answer it in a moment, but okay, something is risk, but okay, advanced, go ahead. And now I add ABC ABPL, and here I get password 123456 say, and again I okay, so again log in. Okay, so now the transmission was not using HTTP but HTTPS. So the port is 44443 is the port, but SSL it should be. Oh, okay, yeah. So here I have SSL connection. So it is secured. And looking at here, we have the content of the messages. We can look at these messages here, but nothing cannot be read because this message is encrypted. So so now I don't know whether we have time. Not okay. So next week, oh, not next week, next year, I will tell you something about encryption. So how it works, why it is so so important, and so on. Yeah. So yeah. So we start from this point. Okay. So first, thank you for your attention. I wish you a Merry Christmas and all the best in New Year, and hope we will meet next year. Okay, so thank you for your attention and goodbye.
Thank you. Merry Christmas.